I'm just sharing my screen. I hope the screen is visible to everybody.
Yes, sir, it's visible.
But before we proceed for confirmatory factor analysis, that is CFA, a little bit about SEM. So primary objective of multivariate technique that you people are learning from last 5 days to expand the researcher's explanatory ability and statistical efficiency, whether it is regression analysis or whether it is factor analysis, whatever the technique it was, the ultimate purpose was to expand our researchers' explanatory ability and statistical efficiency. But one of the major limitations of all these techniques was each technique can deal with single relationship at a time, right? In regression also, where we were studying the impact of independent variables on dependent variable, but each relationship at a time. In factor analysis, we were examining the interrelationship among the variables. So all these techniques are having major limitations of they can examine only and only single relationship at a time. So to overcome this difficulty, the technique called structural equation modeling will be helpful. So when these techniques can be applied, so when we are dealing with some interrelated questions, so our, say for example, in our research, the first research question is that what variables determine a store's image? What variables determine a store's image? So we may identify certain variables, and these variables will be used to represent store's image. So this is our research question number 1. Maybe 5 to 6 variables we will identify that will represent store's image. Then our second research question is, how does that store's image combine with other variables to affect purchase decisions and satisfaction at the store? So again, there are two constructs, purchase decisions and satisfaction. So the store's image is now affecting the purchase decisions and satisfaction. So we need to link the store's image with purchase decisions and store's image with satisfaction. So now store's image is affecting the purchase decision and satisfaction. So satisfaction is dependent, purchase decision is also dependent, and store's image is independent. Now in third research question, how does satisfaction with store result in long-term loyalty? So the satisfaction, which was dependent variable, now it is becoming independent and it is affecting long-term loyalty. So the dependent-independent relationship is being changed in our step 1 to step 2 to step 3. Maybe in the previous step, the variable which was dependent, now it is becoming independent. So there is a link of relationships that we need to identify, and then we need to test these relationships. and all these research questions are interrelated with each other. So whenever a path like a situation that we are going to examine, at that time structural equation modeling will be helpful. Now it is the relationship between the constructs or factors. Earlier what we were studying the relationship between the variables, but now what is that? It is the relationship between the construct. Stores image is a construct which is being represented by maybe certain variables. Purchase decisions is a construct. Satisfaction is a construct. Long-term loyalty is also a construct. So what we are doing, this technique will give us the uh, exact relationship among the constructs. Earlier we are dealing with the variables, but now we are dealing with the constructs. So it is the construct to construct relationship in which the dependent and independent relationships gets translated into the from stage 1 to stage 2, from stage 2 to stage 3, and so on. So SEM, structural equation modeling, is a family of statistical models that seek to explain the relationships among the multiple variables. It examines the structure or interrelationship expressed in a series of equations. There can be a series of equations, right? The first series of equation can be for stores image. Then the second series of equation can be stores image and between purchase decision. Then between stores image and satisfaction. Then between satisfaction and long-term loyalty. So there can be so many equations. It's also a combination of multiple regression analysis because there is a dependent and independent kind of the relationships. So it's a multiple regression analysis also, and it's also a combination of factor analysis because it is a relationship among the factors. What we are studying, relationship among the factors. So the construct will be represented by certain variables. So these variables, this is nothing but the factor analysis in which we were studying the interrelationship among the variables and then we were defining the factors. So this technique SEM is a combination of regression analysis also and factor analysis also. It is also known as causal modeling or analysis of covariance structures. And path analysis and confirmatory and factor analysis are special types of SEM. So the technique that we are today going to discuss is CFA, which is a special type of SEM. Who has developed this technique? So Sewell Wright, he wrote the first paper in 1920. What was his idea? His idea was that y1 is dependent variable, x is independent. So y1 is equal to a1 plus b1 x plus some error term that you are aware because you have already studied now the regression analysis. Now there can be a second situation, y2. So y2 can be represented as a2 plus beta 2 into x, this relationship, this path, plus beta 3 into y3. So multiple paths you are studying in the same model. So this is very simple model. So what are the properties of SEM? It's a model oriented method. We need to specify the model, right? The relationship between the store to purchase decision, store to satisfaction, satisfaction to loyalty. So in a stepwise manner, we need to specify our model. And then at the end of this SEM, it will tell us that whether the data fits into the model or not. So it's not a null hypothesis kind of a method, but it is model oriented method. There can be so many estimation approaches can be applied. Yes, Mohammad Khan, sir.
Hello.
Yes, sir.
Sir, how do we know that it's a model-oriented method. We will come to know from the research question, right?
Yes, from research question we'll came to know.
Okay.
We need to specify in our research question, and if in our research question, if our objective is to study the relationship among the constructs, where the relationship between the constructs gets changed by our research question to research question. Some of our constructs are becoming independent, which were dependent on the previous stage. So in this way, we need to specify the model first of all. Then we will collect the data. Then our purpose is whether the data fits into the model or not. So that is the reason it is called model-oriented method. Then it's a system of linear equations that we have already discussed that describe a network of relationship among the variables. And there are softwares available. For today, we are going to perform this confirmatory factor analysis with the help of MOS. This thing we need to understand that what is a model. So the model is nothing but it's a representation of theory. Without theory, there cannot be model. So it is the representation of theory. Theory can be thought of as a systematic set of relationships providing a consistent and comprehensive explanation of phenomena. This word is more important, consistent. The results that we will get should be consistent. Then only ultimately it will be classified under the category of theory. Theory is not an exclusive domain of academia, but can be rooted in experience and practice obtained by observation of real world behavior. This is also important. We think that theory is purely domain of academia, but it can be rooted in experience and practice obtained by observation. So if we have fair amount of experience and in practice, suppose some kind of relationships we observe consistently, then we may specify this type of relationship, and then we can test this relationship through SEM, right? Pure models, pure theoretical models from academia we also test, but it is not an exclusive domain of academia. From your experience also, from your practice also, if you observe consistent kinds of the relationships, then you can test it through model also. Model should not be developed without some underlying theory. On our own, that let us give x1 as independent and x2 as dependent, and then let us start SEM. This should not happen, right? A sound theoretical base must be present while we come with certain kind of relationships, right? Without the base of literature review or some theory or some practical observations, we should not specify the model. The terms in CFA confirmatory factor analysis or SEM are exogenous variables are called independent variables. Endogenous variables are called dependent variable. Observed variable are called measured, and latent variable or factors are unobserved. We will have score of only observed variable. We will not have a score of latent variable, but that we will estimate. The symbol maybe in the first, just by observing you will not be able to remember everything, but just observe that, and then when you actually perform the exercise with MOS, at that time it will be clearly understood by you. So this symbol is for unobserved or latent factor. This rectangle is for observed variable. This is a relationship between a construct and a measured variable. This is a relationship between two constructs. This is error term in prediction of unobserved factor. And this is error term associated with observed variable. So whenever there is some kind of arrow, it shows the error term. And this is the relationship between construct. This is a relationship between a construct and a variable. This is observed variable, and this is construct or latent variable. There are two types. So first type of structural equation modeling, it is called measurement models. So there are two types of model. First is called measurement model. So in measurement model, it means that how measured variables come together to represent a construct. So our goal in measurement model is that to understand that whether these variables are fairly representing
Yes, sir. Please continue.
okay. These variables are fairly representing our construct or no. So say for example, you are measuring store's image, for example. So store's image can be represented by 5, 6, 7 variables. So these variables will be identified based on literature review. So you are identifying certain variables. Now this variable, your objective is that how this variable are representing our construct called store's image. So there can be a reliability issue, there can be a validity issue that we will check through CFA, and the factor loading should be appropriate, error term should be minimum. So all this we will going to check, and then we will confirm that these variables are fairly representing the construct or not. So this is case number 1, measurement model. Case number 2 can be a structural model. So structural model is once we will examine the relationship of individual construct. At that time we will be checking this measurement model. Once the individual constructs are found okay, all these individual constructs. So for example, we test the measurement model of store image. We test the measurement model of purchase decisions. We test the measurement model of customer satisfaction. We test the measurement model of loyalty. So all these measurement models are found okay. So in the initial exercise, first exercise, if certain variables are found poorly loaded, so we will delete that variable, and then we will be moving further. So in the measurement model only, the deletion of the items will be taken place. Once we establish the each construct, then we will try to study the relationship among the constructs. So this could be the case, and it is known as structural model. So structural model shows how constructs are associated with each other. So what could be the relationship between this construct and this construct? Means, say for example, store image and purchase decision, store image and satisfaction, satisfaction and loyalty. So what is the relationship? So we will be studying the relationship among the constructs. So it will give us the answer that how constructs are associated with each other. So whether the relationship is positive or negative, what kind of relationship it is. So we will be studying this, and it is called as structural models. What are the assumptions of SEM? So regarding the sample size, a good rule of thumb is 15 cases per predictor. So per predictor, what we require at least 15 cases. in a standard ordinary least square multiple regression analysis. Second rule or the assumption for regarding the sample size, that the book of Higher, Babin, Anderson and Tatham, Multivariate Data Analysis, the name of the book. This book is suggesting that your sample size should be in between 150 to 300. Less than 150 is also not good. More than 300 are also not good. So the ideal sample size should be 150 to 300. If you have less sample size, then you need to justify. And higher the sample size, there is a statistics called chi-square statistics. So that chi-square statistics will not be in the optimum range, that we will see in our subsequent slides. So how the sample size can affect the chi-square, that we will understand. But the optimum sample size that is being suggested by this standard book is in between 150 to 300. Confirmatory factor analysis, what is that? Whether we are conducting exploratory factor analysis or confirmatory factor analysis, our basic aim is the same. What was our aim? To describe a large number of observed variables in terms of small number of latent variables or factors. This goal, I think we have already discussed this goal. So EFA is useful when the researcher does not know how many factors there are, or when it is uncertain what measures load on what factors. So if we are not sure that how many factors are present, what is the structure of relationship, then we should do EFA. The potential number of factors ranges from 1 up to the number of observed variable, that you are all aware. All of the observed variables in EFA are allowed to correlate with every factor. All variables are having factor loading with all the factors, but we choose highest one. And then we declare that this variable will be a part of that factor based on factor loading, highest factor loading. An EFA solution usually requires rotation, that you are aware, to make the factors more interpretable. Confirmatory factor analysis is a way of testing how well measured variables represent a smaller number of constraints. So how these variables are representing the construct. So this will be tested by CFA. However, EFA is done with little a priori hypothesis. CFA requires a priori specification based on hypothesis. A model must be present. All these relationships, before running the analysis, we need to establish. And then we will test this relationship with the help of CFA. If it is coming okay, then our conclusion will be whether the data fits into the model or not. CFA model fix cross-loading to 0. It means that if variable x1 is part of f1, then only we will specify the relationship between x1 and f1. We will have a cross loading from x1 to f2, x1 to f3 will be 0. We will not specify any factor loading between unrelated factor and variable. So the variable which is representing that factor, we will fix that factor loading only. We will specify that relationship only. Other cross loadings will be 0. And errors can be correlated. So this is a structure of CFA for a single construct. So this latent variable or factor is being represented by 3 variables. So in this way, software will specify the arrows, and for each of the measured variable, there will be some error. So for observed variable number 1, the error is associated here. Similarly, for second number of variable and for third number of variable. So for each of the variable, the error will be specified. And this arrow is the relationship between the latent variable or factor and observed variable. Suppose there are two constructs or two factors. First factor is being represented by 4 variables. Second factor is being represented by another 4 variables. So we have total 8 variables, x1 to x8. So from x1 to x8, these are our scores or measured variables. Then these two are our constructs or factors. Then delta 1, delta 2, these are our error terms. This one. This lambda 11, lambda 21 are nothing but the factor loadings. So for each variable, the factor loading is associated with their representative construct. And this theta is nothing but the relationship between the correlation between the factor. So we need to specify our model in this way. Suppose we have 5 construct. So the 5 construct will be represented in this way. And then we will give correlation between the constructs. I think there is some question.
Hi, sir. Can you explain this page again, the one you just did, sir, please?
It will be perfectly clear when we will draw the model in MOS, but then also again I am explaining it.
Okay, sir. Thank you. Thanks.
This is a very simple kind of a construct in which we identify the 3 variables to represent the construct. Now suppose we are adding one more construct. So let us assume that we have 2 constructs. So what we have in the beginning stage is scores of only x1, x2, x3, x4, x5, x6, x7 and x8. There are 8 columns. So we will have score of only 8 variables. Based on this score of 8 variables, what information we have? That, for example, that x1 to x4 is store image and x5 to x8 is satisfaction. And we are also aware that x1 to x4 is store image. So this factor, the name of the factor is store image, the first factor, and name of the second factor is satisfaction. We need to estimate the contribution of each variable with respect to factor. So how well we are measuring the store image and how well we are measuring the satisfaction. So through this x1 to x4 we are measuring this store image, but how well we are measuring. So that answer will be given by factor loadings. So the software will give us the factor loading of each variable. At the same time, we need to estimate the error portion also. So these error portions also we need to estimate. Also, we need to estimate the factor loadings. And one more thing that we need to estimate is what is the relationship between store image and satisfaction. How well they are related with each other. What is the correlation between these? So only and only through the scores of x1 to x8, 8 variable, we need to estimate these many parameters. So these parameters will be estimated with the help of the software MOS. MOS will give us all the parameter values. So x1 to x8 are our measured variables. These are our factor. Lambda 11 to lambda 82 are our factor loadings. Yes, Durgesh sir. Durgesh Nandini, please ask your question.
Durgesh Nandini ji, you have raised your hand. You want to ask? So I think mistakenly we raised the hand.
Okay. And then we need to estimate the correlation. CFA versus EFA, I think it is clear to everybody. CFA is theoretically driven approach, EFA is statistically driven approach. CFA has the ability to directly test the specific hypothesis, where EFA does not have that. We specify which items load on which factor before running the analysis in CFA. All items load on all factors. You specify number of factors and their intercorrelations. And here goal is to pick a rotation that gives closest approximation to simple structure. Assumptions of CFA, multivariate normality, first assumption. So this multivariate normality we have already discussed. Sufficient sample size in between 150 to 300 will require, and correct model specification. This is also important assumption, that whatever model we are specifying, this is correct based on theory or based on our past experience. Randomly we should not specify the model. There can be error of identification sometimes when you will run CFA or SEM multiple times. Sometimes you will get the error of identification. So this we need to understand that why it is coming and what could be the probable solutions. So the identification pertains to the difference between the number of estimated model parameters and the number of pieces of information in the variance or covariance matrix. So what is that? Let us again discuss. Let's say, for example, we have an equation like x plus y is equal to 7. Can we solve what is x and what is y by just utilizing this one equation or one relationship, x plus y is equal to 7?
No, sir.
We cannot solve, right? What is x and what is y? So this type of situation is known as not identified or unidentified models. So it means that information we are giving is less than the estimation that we would like to perform. So things we know is less than things we want to know. So it means, just simply means that we want to estimate 5 parameters and then we have only one parameter available. And through one parameter, we want to estimate 5 parameters, and it is not possible. So the information that we are providing to software is less, and estimation that we are demanding are more. So this type of model will called as not identified or unidentified model. So whenever you are getting the error message from MOS that your model is unidentified, it means that the information that you have given to the software is less and the estimation requirements are more. Again, we'll continue this. An unidentified model is one in which the number of parameters to be estimated exceeds the number of variances and covariances. Information that we are giving are less and the estimation that are required for the variances and covariances are more. As such, the model contains insufficient information on the input side for the purpose of attaining a determined solution of parameter of estimation, and that is the reason the software will not be able to perform the analysis, and it will give you message that your model is unidentified. X plus y is equal to 4 and x minus y is equal to 2. Things we know is exactly equal to things we want to know. So it is known as just identified. We will solve what is x and what is y. If these information are given, we will be able to solve these equations. So it is called just identified. But the problem is just identified models can never be wrong, right? It will be right all the time. So normal statistics are just identified. Then the third kind of a situation, just identified, number of data variances and covariances equal number of parameters to be estimated. Whatever we want to estimate, exactly that information we have. However, despite the capability of the model to yield a unique solution for all parameters, the just identified model is not scientifically interesting because it has no degree of freedom and therefore can never be rejected. This type of model can never be rejected because of 0 degree of freedom. So we require some degree of freedom. So that is the reason we need to again require some more degree of freedom to perform the analysis. So the third kind of model will be like this: x plus y is equal to 4, x minus y is equal to 2, 2x minus y is equal to 3. We have more information. We have 3 equations and just we want to estimate only 2 parameters. So this type of situation is known as over-identified, and SEM models are over-identified. So to run the CFA or SEM, we require that our models must be over-identified. Some space of degree of freedom must be there. Then and then we will be able to perform the analysis. Otherwise, software will not give us the output. So an over-identified model is one in which the number of estimable parameters is less than the number of data points. The situation results in positive degree of freedom that allows for rejection of the model, thereby rendering it scientific use. So SEM and CFA requires over-identified model. So the model that we are specifying must be over-identified. So how can we know at the beginning, on the beginning stage, that whether our model is just identified or under-identified or over-identified? So let us discuss that. What could be the items per construct ideal situation? So say for example, we have a construct which is being represented by two things, two variables, x1 and x2. So information we will have, this information will be the scores of x1 and scores of x2, nothing more than that, right? So we have variance of x1. So from the scores of x1, we can calculate variance of x1. We can also calculate variance of x2. And we can also calculate covariance or correlation between x1 and x2. So information that we have is variance of x1, variance of x2, and covariance between x1 and x2. Now let us see that what parameters we need to estimate. So parameters that we need to estimate are two factor loadings, delta 1 and delta 2, lambda 1 and lambda 2, and two error terms, delta 1 and delta 2. So we need to estimate 4 parameters. How many informations do we have? We have 3 pairs of information: variance of x1, variance of x2, and covariance between x1 and x2. So what do you think? Will it be sufficient for us to estimate these 4 parameters?
No, sir, no.
It will not be sufficient, right? So the message that we need to understand is we require more than two items or variable per construct. But more than 2 means how many? So let us add one more item and then check it. So this model will be unidentified. If we have 2 variables only to represent a construct, then it will be unidentified. Let us add one more variable. So now we have 3 variables, x1, x2, and x3. Now what information we have? Variance of x1, variance of x2, and variance of x3, and covariance between x1 and x2, x2 and x3, and x3 and x1. So 6 pairs of information we have. Now, what we need to estimate? We need to estimate the parameters of 3 factor loadings and 3 error terms. So total 6 parameters we want to estimate, and at the same time we also having 6 kind of information. So this kind of situation is known as just identified model, and we are aware that in CFA or SEM what we require over identified. So 3 variables are also not enough. So let us add one more variable, 4 variables, and then see. Now the information that we have 4 variances from x1 to x4 and 6 covariances in between x1, x2, x2, x3 like this. So the information we have are 10 points of information we have. Can anybody tell me how many parameters do we need to estimate in this situation? 8 pairs. 8. So we need to estimate 8 parameters and we have 10 points of information. So it is perfectly okay. So this kind of situation will be considered as over-identified model, that is perfectly fine for CFA and SEM. So the message that we need to understand is at least for a single factor or construct, we require 4 variable or items. At least. More than 4, okay, fine, good. But not less than 4. 3 will give us a just, yes, Mohammad Khan sir. Mohammad Khan sir, please ask your question.
How many construct do we need, sir? Per construct require 4 items, right, sir?
How many construct do we need? You can put as many construct as possible depending upon your research objectives. There are no limitations for constructs.
Okay, sir. For CFA,
but for individual construct, you require at least 4 items.
4 items. Okay, sir.
Right. So, say for example, sometimes you will not get at least 4 items for construct. So, on an average, the message is on an average you require 4 items. On an average, at least.
But
so, if it is in some of the construct, it is 3. So if in second construct you may have 5 to 6 items, so that will balance the things.
And if you put 10 items per construct, is it okay?
Suppose for a construct you have 3 items. For example, you are not getting the 4th one, but there is another construct in which you are getting 6 items. Right. So 3 plus 6 are 9 items for 2 constructs. So the average will be 4.5 items. So that will be perfectly okay. On an average, you require 4 items per construct.
Okay, but if it's more than 4, sir, like say if it's 10 items per construct, is it okay?
In the initial stage, it will be okay. Maybe 7, 8, 10 items. Because if you will have certain poor factor loadings, then in the initial stage, these items will be deleted. What we require at least 0.7. The factor loading that we require is 0.7. But when we run the analysis, maybe 1 item or 2 items will have a poor factor loading with that factor. So these items will be deleted. So if it is more than 5, 6 items, then it will be safer side for us that even if we delete 1 or 2 items, then also on an average we will have more than 4 items per construct.
Okay, so thank you, sir.
Okay. So the number of indicators, 2 is minimum, 3 is safer, especially as factor correlations are weak, 4 provides safety, 5 or more is more than enough. So when you start CFA or SEM, you start with more than 5, maybe 6 to 7. And then when you will finish that one, you will end up with 4 to 5. So the software will have this kind of equation: rho into rho plus 1 divided by 2, degree of freedom. How the degree of freedom will be calculated? So it is rho into rho plus 1 divided by 2 minus number of estimated parameters. So if the answer is positive, then the model is over identified. If the answer is 0, it is just identified. And if it is less than 0, then it is under identified, where rho is nothing but your number of variables, measured number of variables. CFA will also give us the answers of validity. So how we can check the validity with the help of CFA? So one of the biggest advantage of CFA or SEM is its ability to assess the construct validity of a proposed measurement theory. So what is the construct validity? It is the extent to which a set of measured items actually reflect the theoretical latent construct they are designed to measure. How well this construct is being captured. So construct validity will have these many components. First component is known as convergent validity, and second component is known as discriminant validity. If we found convergent validity okay and discriminant validity also okay, then we can say that the construct validity is perfect. So for convergent validity, we require 3 things to check. First thing is factor loadings. Second thing is average variance extracted. And third thing is reliability. So these 3 things will give us the answer of convergent validity. So ideally factor loading should be greater than 0.7. Average variance extracted should be greater than 0.5. And reliability should be greater than 0.7. Factor loading should be greater than 0.7 ideally. Average variance extracted AVE should be greater than 0.5. And reliability should be greater than 0.7. If these 3 things are okay, we can say that convergent validity is okay. And there is the discriminant validity that we will also discuss. So the construct validity is nothing but convergent and discriminant validity. Standardized factor loading estimate should be higher than the 0.5 or ideally 0.7, but I recommend 0.7. Each factor loading should be greater than 0.7. Variance extracted AVE should be 0.5 or greater. Now variance is nothing but the average variance extracted. So it is nothing but the squares of the factor loadings and then summation of all these and then dividing it by the number of items. Say for example, let us take very simple example that we have only 2 items, x1 and x2 for simplicity. And their factor loadings are 0.7 in both the cases. For x1, which is loaded on factor number 1, the factor loading is 0.7. For x2 also the factor loading is 0.7. So the factor loadings are greater than 0.7, so it is one of the green signal. Now how to calculate average variance extracted, AVE? So we need to square the factor loadings. So 0.7 square will be 0.49 plus second factor loading is also 0.49, 0.7 square, so 0.49 and then 0.49 plus 0.49, so plus 0.98, and dividing by number of items. So there are 2 items. So roughly you will get answer of 0.49 only. So that is the reason I recommend that at least your factor loading should be 0.7 or greater than 0.7. Then only you will get the answer of AVE 0.5 or greater than 0.5. At least if it is in 0.7, then 0.7 square will become 0.49. So roughly you will get 50% average variance expected. So do you understand how to calculate AVE, average variance expected? Software will give us answer, everything, don't worry. But we need to understand this. So AVE will be like this. It is nothing but the average variance. And construct reliability, Cronbach alpha should be greater than 0.7 or higher. And one more thing is variance extracted, means AVE, average variance extracted, estimates for 2 factors also should be greater than the square of the correlation between the 2 factors to provide evidence of discriminant validity. So idea of discriminant validity is that average variance extracted AVE is nothing but how much the individual construct is explaining how many percentage of variances. Now, if the 2 constructs are separated from each other, then their discriminant validity should be higher. So how can we check the discriminant validity? That average variance extracted should be higher. Why? Because the construct should explain more with itself rather than sharing with the other construct. If the construct are very similar, then they will share more of the things, and then the correlation will be higher. So what ideally we require, that the correlation between the factors should be low and average variance extracted should be higher. Then and then we can say that these 2 constructs are separated from each other and discriminant validity we have established. So to check the discriminant validity, what we need to do, that we need to square of the correlations between the 2 constructs, and then the square of the correlation should be less than the average variance extracted. Your questions, if it is. Okay. Now, what are the steps of CFA and SEM? So stage number 1 is defining individual constructs. So we need to define the individual constructs based on literature review, that these variables are identified and they are representing our constructs. So based on literature review, we are going to identify the variables that are being represented through the constructs. Developing the overall measurement model. So how measured variables are representing our construct. So this is nothing but the measurement model. So we need to develop the measurement model. Then designing a study to produce empirical results. We need to collect the data. Then we need to assess the measurement model validity. So the construct validity we need to measure, and for that we require convergent validity and discriminant validity. Then specifying the structural model, means the relationship between the constructs, and then assessing the structural model validity. Now CFA involves stages number 1 to 4. So at CFA today we will stop at stage number 4. Stage number 5 and stage number 6, if we will include, then it becomes SEM, structural equation modeling. So from stage number 1 to stage number 4, it is CFA. If we include step 5 and step 6, then it will become SEM. So in CFA, what we are doing, just we are testing the relationship of the measurement model, overall measurement model. And then we are testing the reliability and validity part of measurement model. Once the measurement models are found okay, then further investigation between the relationship of the construct can be tested with the help of structural equation model. Defining construct, list construct that will comprise the measurement model. Determine if existing scales or constructs are available. This is most desirable, or can be modified to test your measurement model. If existing scales or constructs are not available, then develop new ones. But developing a new construct is again a lengthy procedure. And if the existing scales or constructs are available, we must go through this adoption of scales through the literature. Then rule of thumb, all construct must display adequate construct validity. So that we will check whether they are new scales or scales taken from previous research. Each previously established scales should be carefully checked for content validity. Content validity, as you are aware, that it is a theoretical type of validity. So based on literature review, whether the content that you have identified to represent a construct is appropriate or not. So for that, your maybe a PhD guide will tell you, maybe some expert domain, from your domain you need to identify certain 2 to 3 experts, and then you need to send the questionnaire to them. They will tell whether the content is okay or not. So there are no empirical testing of content validity. Through the suggestions of the experts, you can establish the content validity of your questionnaire. Experts should judge the item's content for validity in the early stage of scale development. When you develop the questionnaire, before collecting the data, you should establish the content validity. When 2 items have virtually identical content, one should be dropped. Items upon which the judges or expert cannot agree should be dropped. Right? If more than one judge is saying that this item should be dropped, if 2 judges are saying that item should be dropped, the item should be dropped. Once the first kind of the purification exercise you perform through content validity part, then a pre-test should be used to purify measures prior to confirmatory stage. So a pre-testing should be done with some small kind of samples, and then you should go for a full-fledged study. Developing the overall measurement model. So the model that you are establishing should be unidimensional. And then item per construct identification, all this issue you need to check before collecting the data, right? The item per construct at least 4 or more you should select. Designing a study to produce empirical results. So measurement scales in CFA, SEM or CFA and sampling, specifying the model. This issue we will be discussing in our subsequent slides. So the scale of latent construct can be set by either, because why we need to fix the scale? Software automatically will fix. But why software fixes it? Because it is a latent or hidden or the factor, and you are aware that there cannot be a measurement of the factor directly, and that is why it is called a latent variable. So latent variable cannot be measured directly, but we need to initiate the process to establish the relationship between the constructs. So how can we establish the relationship between the construct? So initially what we need to do, the software will fix one of the loading as 1. So fixing either one of the factor loading as 1 or fixing the construct variance to 1. So software will give us, MOS will give us a value of 1 to one of the individual variables factor loading, so that the process can be started. Why we require to initiate the process? Because we need to establish the relationship between the constructs. But at the initial stage, we do not have any scale, because latent variables are just unobserved variable. So for unobserved variable, how can we have any scale? So to have a hypothetical scale, software gives a value of 1 and then it will starts the process. It will automatically give 1, and then even if you do not specify, it will automatically give 1 and it will start the process. Recognizing the identification problem, the software will give you the identification problem that the your model is unidentified or your model is just identified. Sometimes you will get some poor results regarding the model fit. So once you will get the poor results, then you need to further investigate why these poor results are coming, why my model fits are lower than the recommended value. So when this type of results will come, then at that time you need to check these things. So what are these things? Very large standard errors. If you check the standard error, then your standard error will be very large. Inability to invert the information matrix, no solution can be found. If there is a problem of identification, then the message will appear that no solution can be found. So what you ideally you require, either you need to delete certain variable or construct to simplify the model, or you can add some of the variables if it is possible. And unstable parameter estimates. So generally the standardized estimates are lesser than 1, but you will get higher than 1. So this is called unstable parameter estimates. So if this kind of situation or results you are getting, then probably your model fit will not be appropriate. So then you need to solve this problem by either deleting certain variables or maybe simplifying the relationship among the constructs. Assessing measurement validity. So then the validity part, the construct validity, we have already discussed, and within the construct validity will require convergent validity, reliability, and discriminant validity. Then assessing the fit are the goodness of fit, construct validity, and then if the problems are that, then with related to path estimate, there can be a problem. There can be a standardized residual that will give us the solutions of the problem, and then we need to go for modification indices. So the modification indices is nothing but if the values of the model fit are not according to the recommended value, then we need to go for modification indices. So how we can go for modification indices? When we will run the MOS part, at that time we will discuss that how we can go for modification indices. So validity part we have already discussed that ideally the factor loading should be greater than 0.7. Completely standardized loadings above +1 or below -1 are out of the feasible range. This should not be greater than 1 or -1, less than -1. So if the standardized factor loadings you are getting as greater than 1 or -1, it is just saying that this variable should be removed from your analysis. Then the next problem can be a standardized residuals. So standardized residuals less than 2.5 plus 2.5 do not suggest a problem. But standardized residuals greater than 4 suggest a potential unacceptable degree of error that may call for the deletion of an offending item. So if for any variable, if the standardized residuals are greater than 4, then ideally again this variable or item should be deleted. Standardized residuals between 2.5 and 4 deserve some attention but may not suggest any changes to the model if no other problems are associated with those items. So in between 2.5 to 4, it is acceptable. Less than 2.5 are perfectly okay, but greater than 4 should be deleted. So what you need to do, you need to check the standardized loading. If any case, if it is greater than +1 or less than -1, you should delete it. You need to again check the standardized residuals. Greater than +4 should be deleted. Then measurement model validity, the researcher should use the modification indices only as a guideline for model improvement of those relationships that can theoretically be justified. Sometimes what happens that the model fits that we are getting are not sufficient. For example, one of the parameter or the model fit parameter is CFA. So CFA value, the thumb rule is that it should be greater than 0.9. But when we run the analysis, for example, it is coming as 0.82. So it is less than 0.9 and it is not acceptable. So we are checking that whether we can improve this CFA value or not. So there are certain ways and means in which we can improve the model fit or CFA value. So one of the ways and means is that we go for modification index. So in modification indices, we are giving errors to the correlation. In our base model or original model, we are not giving any correlation between the error terms. But as the model fit values are low, we will go for correlating the errors. But it is saying that if it is justified, then only you should correlate the errors. Otherwise, you should not correlate the error. So within the construct only, you should correlate the errors. Right? Between the construct, the error should not be correlated. That you should keep in mind. Suppose there are 3 constructs and 20 variables. So for example, for the first construct, there are 5 variables. So within these 5 variables, you can give the correlation between the errors. But for the first constructs and second constructs, the errors of the variables should not be correlated. It will be more clear once I will open the AMOS part and then we will run the analysis. Model fits. Here, the model that you are specifying, how do you know that whether the data fits into the model or not? So there are 3 types of model fit that the software will produce. First kind, it is called absolute fit. Second kind, it is called incremental fit. And third kind, it is called parsimonious fits. And there are more than 20 to 30 kinds of measurement fits that the software will give us. So what ideally the general practice are that from absolute fit 3 to 4 kinds of the measurements the researchers are specifying. In increment fit again 2 to 3, and from parsimonious fit again 2 to 3. So around 7 to 8 kinds of the model fit you need to just yes, Ramesh Chauhan sir. Ramesh Chauhan sir, please ask
Sorry,
your question.
actually he mistakenly raised the hand.
Okay sir. Okay. So within these 3 category, 1, 2 or 3 model fit, you can just give it. So 7 to 8 kinds of model fit values you can report in your research paper or thesis. There are no need to give all this, whatever the software is producing. There is no need to give all the values. Just recommend the report those values which is in standard practice. So only 7 to 8 values are into the standard practice. So absolute fit, incremental fit, and parsimonious fit. So in absolute fit, the standard practice is that we report GFI and AGFI values. So it is a goodness of fit, how well your data set fits into the model. And badness of fits are nothing but the error terms. So within this, there is a chi-square test, then there is a RMSEA. These two are the more popular reporting values. So researchers generally report chi-square value and RMSEA, that is root mean square error of approximation. And then goodness of fit, generally researcher prefer GFI value. And then incremental fit, one or two values only you can report. So NFI or CFI you can report. Parsimonious fit, you can either report PGFI or you can either report PNFI. So certain 5 to 6 values you can report. So this is a table I have produced. So these are the values from each of these fit measures. Absolute fit, relative fit, and parsimonious fits. So in absolute fit, chi-square values, the recommended value is that the p-value should be greater than 0.05. But hardly you will get this, because the sample size, if the sample size is larger, the chi-square statistics will not give us a p-value greater than 0.05. So it will be always it will be lesser than 0.05. But some other researchers are suggesting that this is C mean is nothing but the chi-square value, calculated value of chi-square, and then divided by degree of freedom. So this ratio should be less than 3, and this is important. It should come as less than 3. Even if your chi-square is not coming as p-value is not coming less than it is not coming greater than 0.05. If it is coming less than 0.05, then it is okay, but this ratio should come less than 3. And then error term, RMSEA value should be less than 0.1. So majority of the goodness of fit value, the software is the authors are recommending as 0.9. So goodness of fit is 0.9, means 90%. The data should fit into the model. So if it is 90%, then error term automatically it will come as 10%. So that is why 10% means 0.10. So that is the reason that the error will be 10% and goodness of fit value thumb rule will be around 0.90. So that is the reason root mean square error of approximation RMSEA value should be less than 0.10. Then CFI, NFI, all values should be greater than 0.9 ideally. And for this parsimonious value, it should be greater than 0.5. So in this way, you should report in a table format. And what is the value in your whatever reporting model? You need to put your values here. So a better comparison can be done. Chi-square is the chi-square test. C mean by DF is chi-square test divided by degree of freedom. This is root mean square error of approximation. CFI, the full form of CFI is comparative fit index, normed fit index, NFI, RFI is relatively fit index, IFI is incremental fit index, parsimony comparative fit index, and parsimony normed fit index. So these are the full forms of this test. So the equation of the chi-square is this. Chi-square is equal to n minus 1 into observed matrix minus estimated matrix. So if we forget this portion, observed minus expected matrix, then the value of chi-square will always depend upon n. As the sample size n increases, the calculated value of chi-square will always increase, irrespective of this difference, observed minus expected. So as the sample size increases, the value of chi-square will get increase. And if the value of the chi-square will get increase, their p-value will be smaller. So higher the calculated value of chi-square, lower will be the p-value. And it will turn as less than 0.05 of the p-value. But actually what we require, greater than 0.05. So because this problem is because of our higher sample size, So we will divide this value by degree of freedom n minus 1, or this is called so by dividing it, then the problem of sample size will get rectified. So the chi-square statistics is the most frequently cited index of the absolute fit. Probability of the chi-square should be greater than the chosen alpha level, 0.05, but it compares the observed covariance with the theoretical proposed covariant matrix. A non-significant result indicates no statistically significant difference between the actual covariance and our proposed model to explain this covariance matrix. So ideally, we require sample size that we have already discussed. So Klein in 1904, he recommends evaluating the chi-square result in relation to the degree of freedom. And he has given this ratio chi-square divided by degree of freedom, and this should be less than 3. So even if in your case also, if the p-value of chi-square is coming as less than 0.05, then also it is perfectly okay. Just check the chi-square divided by degree of freedom. It must come less than 3. Then this CFI and all these values should be greater than 0.9. RMSEA value should be less than 0.1. Now let us open the software called MOS. My audio is not coming. Is it coming low?
No, it's okay.
Okay, okay. Okay, fine. I am just sharing the screen. You open the file called measurement theory model. Measurement theory model, but that this is the SPSS file that you need to open. And at the same time, again, you open the Word file called Confirmatory. You open the Word file called Confirmatory. These are the statements related to these constructs. The construct number 1, OC. What is OC? That is organizational commitment. So organizational commitment are measured by 4 variables: OC1, OC2, OC3, and OC4. So this OC1 is what? My work at XYZ gives me a sense of accomplishment. So these are the statements: OC1, OC2, OC3, and OC4. Second construct is staying intentions. And staying intentions are measured by S1, SI1, SI2, SI3, and SI4. Staying intentions. So the statements of the SI1 staying intention is, I am not actively searching for another job. SI2 is, I seldom look at the job listing on Naukri.com, SI3, SI4. So in this way, this staying intentions is being measured. The third construct or factor is environmental perception. And environmental perception is EP. So EP, the statements of EP1, EP2, the environmental perception one is I am comfortable with my physical work environment at XYZ. Then for EP2, the place I work in is designed to help me do my job better. So in this way, the statements environmental perceptions are represented. The next factor is attitude of co-workers. So attitude of co-workers is being measured in terms of SE1 to SE4. There are 4 variables: SE1, SE2, SE3, and SE4. So these are the 4 last variables. SE1 is how happy are you with the work of your co-workers? How do you feel about your co-workers? SE2. So in this way, attitude of co-workers is measured. The last construct is job satisfaction. So job satisfaction is again it is represented by JS. So JS1, JS2, JS3, JS4 and JS5. There are 5 variables. So JS1 is all things considered, I feel very satisfied when I think about my job. So in this way, these are the statements. Around 400 respondents we have collected, and the SPSS file is being shared with you for this.
Sir, what was AC? AC was what?
AC is attitude of co-workers.
Okay, sir. Okay.
OC is organizational commitment. SI is staying intentions. EP is environmental perception. AC is attitude of co-workers, and JS is job satisfaction. So there are 5 constructs or factors. All factors or constructs are being measured by 4 variables except for job satisfaction, which is measured by 5 variables. Now for your understanding, first of all, just I am sharing the file of the MOS, that which model and what kind of model we need to draw. So that I am sharing this. This model we need to draw. Right? OC, in this way we will need to establish the relationship, staying intentions, environmental perception, attitude of co-workers, and job satisfaction. These are the 5 constructs. So this model you need to draw. So first of all, you just open the data file measurement theory model.sav SPSS file. Are all participants ready with the file, SPSS file?
Yes, sir.
Okay.
Yes, sir.
In your file, I have given the labels here. All these statements are there, right? In label, if you click on variable view, there are labels here.
Yes, sir. Yes, sir.
You just delete these labels. Make this portion as blank. and save the file. Have you cleared the label part?
Yes, sir.
Yes,
Okay.
sir.
Okay. Now you click on Analyze, then IBM SPSS MOS. Once you will click there, the screen of MOS will appear. Are you able to see my screen of MOS? Let me again share it. Okay. I think now it is visible.
Yes, sir.
I have already given a ready-made file to you. So we can also do exercise with that. But initially we need to learn that how to draw it. Right? So first of all, on this blank screen, our first task is to draw a single construct. The name of the construct is organizational commitment. Right? And then we are aware that OC1 to OC4, the 4 variables will require. So we want to draw only one construct at this moment of time.
Yes, sir.
The MOS portion is not visible. MOS file, the blank screen of MOS.
It is visible, sir.
Okay. So to draw any construct, we need to click here. Once you will click here, you can just read that it is written as draw a latent variable or add an indicator to a latent variable. So we need to draw a latent variable named organizational commitment. So we'll click here and just observe. Once you need to click here and then you need to left click here. Once you will left click here, this factor will come. And then you know that 4 variables you need to add. So 4 times you need to left click. So 1, 2, 3, and 4. 4 times I have left click. So these 4 variable will be emerged. Automatically software has given 1. You just do it. Maybe you may have some problem because the first time you are doing it. What you need to do, you need to just click here and then again you need to click here and then 4 times you need to do the left click. If anybody is having any problem, please let me
Do
know.
we need to click and drag it, or we need to click and then click on the blank space only?
Only blank space. You will click it. No, there is no need to drag it. You need to just click here. And then 4 times left click. Everybody is ready. I hope they are able to do this.
Yes,
All?
sir.
Okay, very good. Excellent. Now, if we want to change the layout of these 4 construct, then what we need to do, this one, rotate the indicators of a latent variable. So you just observe me and then do it. You need to click this arrow, this round circle. They rotate the indicators of latent variable. You need to click here. So the rotate, it will appear as rotate. So one click I have given, one left click, so it is giving rotation like this. One more left click, so like this. One more left click like this. So it is okay. I want this type of layout. If again I will give a click, then it will become what it was earlier. So 1, 2, and 3 left clicks. You need to
Done,
click
sir.
on rotate and 3 left clicks.
Yes, sir. Done.
Now you are aware that there are 5 factors, and factor number 1 to 4, there are 4 variables. So factor number 1 to 4, the structure will remain same, right? But from the 5th one, there are 5 variables. So what we'll do, we need to do the copy paste. Just a minute. Sir, can you repeat from first? I lost my connection due to network problem. Okay. So there is a blank file. First of all, what we are doing, we need to just draw our first factor. The name of the first factor is organizational commitment, OC, and this OC is being measured by 4 variables. So you need to left click here, and then you just on the blank space, you need to just click it here. So this factor will be appear, and then 4 times you need to just give the left click. So 1, 2, 3, and 4. So this 4 factor structure will be present. Then I have given the rotation. So to give the rotate, I have just used this indicator. I clicked here, and then 1 times, 2 times, and 3 clicks. So this is my
Sir, which indicator are you seeing?
this one, this rotate the indicator of latent variable. You are able to see this. Rotate the indicators of latent variable here.
Middle.
Middle one.
Am I audible? Sir?
Please.
Sir, I am unable to bring this blank screen. Where I have to bring this screen?
From SPSS, you need to click on analyze, and at last you will observe that MOS 18. Once you will click that
First,
part,
you want
MOS.
to clear and label.
What?
Asked to clear a label. Which one label I could?
You open the SPSS file.
Yes, sir.
Click on analyze, and then last one, IBM SPSS MOS. Did you get that blank space, MOS?
Yes.
Okay.
Sir, even I have a problem, sir. On my screen, it is, looking like license validation problem, sir. It is showing the
So-
temporary period for running a MOS without a license is
Sir, I
expired.
think we need to proceed. Otherwise, time will not permit us to complete the.
So
This is a
you
simple
have
request.
not done that second part that initially I explained, right?
Sir, actually, I was
So
in
we are live,
college.
so we cannot discuss at this moment of time, and we need to proceed it. We'll discuss it afterwards. How to do the installation, we'll discuss it.
Okay, sir.
Okay. So on my screen is visible, blank screen.
No, sir.
Just a minute. Now I hope it is visible.
Yes, sir.
Okay, okay. Just a minute. So the first construct, the layout is okay. Now 5 times we want to copy this. So how can we do this? Just observe me and then you will do it. So these 3 hands, first left one is saying select one object at a time. The second one is saying select all objects. And the third one, it is saying deselect all objects. So I want to select it first. So all objects, this symbol, second one, I will select all objects. I will click here. Once I will click here, this entire my first factor structure becomes blue, right? Then what I need to do, I need to copy it. So I will just click on this symbol. Duplicate items, this one, duplicate objects. I will click here, left click, and then again I will give a left click, and then I will drag it like this. One time dragging will copy a same structure. Second time dragging will copy a same structure. Third time again. Fourth time again. So I have now 5 factors. You need to do like this. Should I repeat it one more time?
Yes, sir. Yes, sir.
Okay. Now you will do with me. Okay. So what you need to do, the second one, select all objects. So just click on select all objects. So this first factor will become blue. Okay. Should we proceed?
Yes,
Yes.
sir. Yes, sir.
Okay. And now left click on duplicate objects, this one. You just click one time, and then you click it here and drag like this. Are you able to do this?
Yes, sir. Yes, sir. Yes, sir.
Okay.
Absolutely.
One more time. One more time. You click here and drag it like this.
Okay,
One
great,
more
great,
time.
sir.
And one more time.
But in last we need 5 now.
Last we need 5. Yes. So we will add one. Don't worry. We will add one.
Okay, sir.
Right. And once the 5 factors are available, you need to click here, deselect all objects. So once you will click on deselect all objects, so this will become again in original format.
Okay, sir. Okay.
Everybody is with me?
Yes, sir. Yes, sir.
Okay. Now what we require for the last.
Sir.
Yes,
Hello.
please. Yeah.
सर एक कंस्ट्रक्ट के अंदर मैक्सिमम मिनिमम कितनी आइटम्स होनी चाहिए, क्योंकि कई बार ऐसा होता है कि एक कंस्ट्रक्ट के अंदर 10-12 स्टेटमेंट्स होते हैं, तो यहाँ पर उसको सेट करना इट बिकम्स डिफिकल्ट.
We discussed that at least we require 4 items per construct to have to avoid the identification problem, right? But
Okay,
10
sir.
to 12 items again much more items, right?
Okay.
So 5, 6, 7 items are more than enough per construct.
Okay, sir. Okay. Thank
Now for
Excuse
the
me, sir.
yes, please.
Sir, I've created this diagram, but what if my constructs are more than 5? How will I resize it? Because it will not fit on the
There is
page.
so many space available. You can have
Sir,
6 construct here, 7, 8, 9, 10, 11, 12.
So, but usually I've seen in papers, it's a one big diagram with all the constructs one below the other, so that the neatness is maintained. I'm not able to achieve that. Can you help me with that?
In the initial stage, you will not be able to do the perfect diagram. Only through practice only you will be able to manage the space, whatever is given. But here you will have the options of, let me check, the inference property maybe, yes. Click on diagram, view, and then interface properties. And in interface properties, you can have your page layout. Then in your page layout, you can have paper size, and then you can change it from portrait letter to maybe a bigger size one. Or maybe what you can select, a landscape also you can select. If a larger kinds of relationships are present, then you can change from landscape to portrait. Portrait to landscape.
Got it, sir. Thank you. Thank you so
Sir, I
much.
think once the hand is set, we can get it done in this paper
Yes.
only.
Yes.
So please proceed.
Now for the fifth factor, we require the 5 variable, but we have only 4 variable. So we want to add 1 variable. So how can we again add? Just again we need to click here, draw a latent variable or add an indicator to a latent variable. Once you will click that, left click, and then 1 click here. So it will add 1 variable. You need to click it here, and then you need to just click it here.
Okay, sir, got it done.
Okay. Now
Yes,
we
sir.
need to
Perfect.
specify the data files. Right. So the data file, to specify the data file, we need to click it here, select data files. You click here, select data file. So these will emerge, data files. Click here, file name.
Sir, please repeat this. From where we have to select the data file?
Okay. From this option, select data file. This one. Okay. Once you will click here, this will emerge. Click on file name. Click on file name and then select a file called measurement theory model. Measurement theory model. The file that I have shared with you, measurement theory model. You need to click it here and then click on open. So once the file is selected, it will show the name of the file as measurement theory model and 400 by 400. So sample size is 400. And then just give OK. So file is selected. Okay.
Yes, sir. Yes, sir.
Yes, sir.
Okay, very good. Now we need to specify the variables. So the first factor is OC. So we need to specify from OC1, OC2, OC3, and OC4. So you need to click it here, list variables in dataset. List variables in dataset. Once you will click it here, the variables names will appear. Now, if you have not cleared that labeling part, then entire sentences will be displayed that we do not require because the space is limited. Entire sentences cannot be put into the squares. That is the reason we have deleted the sentences. So what we require, a very small name. So that is why we require OC1, OC2. In this way, the names of the variables should be given. Now I am transferring OC1. So I am just left clicking here on OC1 and drag it to this one. So once you will drag it perfectly, the box will become red, and then put it here, OC1. Again click on OC2, drag it, put it like this. OC3, put it like this. OC4, put it like this.
Done, sir, done.
Okay. The second factor is SI, staying intentions.
Excuse
So
me, sir.
from, yes, please.
Sir, when I'm dragging OC1, the entire 4 variables are getting labeled as OC1. Am I?
You need to drag it to only the first one. What you are doing, you are putting it into all this one. So only a single variable should be transferred into a single box. So say for example, staying intention I am transferring. So staying intention I am doing, and then I am dragging it to here only. Only one box should get red, this one. So it is perfectly okay. I am just transferring it SI. Just do like this and it will be okay.
Sir, a circle and cross like stop type of symbol is coming. What does it mean when I'm selecting it?
What symbol is coming?
A circle which is like crossed from the middle.
I am not getting that one.
When I'm selecting this variable, a circle is coming, wherein it is like there is a diameter sort of thing in between the circle, which is not allowing me to select. Okay, maybe I might have done something. We can proceed, sir. No issue.
I believe that is action not allowed.
Then EP, EP1 to EP4. So select this EP1, EP2, EP3, and EP4. You have second option available, but I do not recommend this to write the name of the variable. Once you will double click on that.
Done, sir. Now it is working.
Good. Once you will double click on that, this second option. At present, it is not active. Maybe I have not saved the file. But then also you can write the name of the variable.
I have got it, sir.
Yeah. Then the next one is attitude of workers, SC1 to SC4. So we'll select SC1 to SC4 here. And then the last one is job satisfaction, JS1 to JS5. So JS1, JS2, 3, 4, and 5. And then you close it. Everybody is with me?
Yes, sir.
Yes, sir.
Now let us give some name of this file. So click on File, click on Save, and then you can give a name as CFA or whatever. CFA or whatever name you want to give, and then save it. Once you will double click here on this factor, then you can write the factor name. So once double clicking the variable name, you just give it to organizational commitment, but very short name we will give. So I am giving org underscore com. Then once you will click it here, again you can give a name, staying in intention, st underscore in. Then environmental perception, you can give en underscore pe. Attitude of co-worker, you can give ATT underscore co. And here you can give job underscore s. And then you can close it. Everybody is with me? The name, if you wish to give the name, you can just double click here and then you can type the variable name.
Done, sir. Done.
Everybody is with me? Should I continue? Okay. Now click
Yes,
on
sir.
plugins. Once you will click here, plugins, then there is an option of name unobserved variables. So once you will click there, all error terms will get their name automatically. So just click here, name unobserved variable, and then you have observed that all variables are error terms are giving the automatic names.
Yes, sir. Done.
Okay.
Yes,
Now what we require to specify the correlation between the factors. So between these, all these correlations we require. So for that, we need to select first of all our factors one by one, only the factors, not the variables. So just observe me. I am clicking select one object at a time, this left one. So I have just left click it. I have just clicked on org underscore com, first factor, so it become blue. Second factor, so it became blue. Third one, fourth one, and fifth one. Only the factors should be selected. Only the 5 blue marks we require. Everybody is with me?
Yes, sir.
Okay. And then click on plugins.
Repeat this last point.
We need to select these 5 factors one by one. How can we select? Select one object at a time and then clicking on the factor. So one by one we need to click here. So it will become blue. Only the 5 blue marks I need, not more than that. Then just click on plugins. And then there is an option of draw covariance. Draw covariance. You click it here. So automatically all correlations will be established. Plugins, the first option, draw covariances.
So, sir, this covariance relations has been like visible because of the data set that is already provided to it because of the nature of data and the
No.
it has.
No.
Okay.
Data set, why we attach? Because we wanted to identify these variables, OC1 to all these things. We wanted to drag it.
Okay, sir. Okay.
Now we will deselect. So deselect all objects. Just click that. So it will become perfectly okay. Now, if you wish to change some structure or the layout, then this one, resize the part diagram to fit on a page. This one, resize the part diagram to fit on a page. You just click it, so it will resize automatically. Okay?
Yes, sir.
Everybody is with me?
Yes, sir.
Now you click on analysis properties. Analysis properties. Once you will click it here, see, for SEM, we do not require a single missing value. In our data set, we do not have any missing value at present. But in future, if you have some missing value, then ideally you should replace it with the average value. If you are not able to replace it with the average value, then what you need to click? You need to click it here. Estimate means and intercepts. At present, we need not to give it a tick mark to here because we do not have any missing value. So we will not give any tick mark. But in future, if we have any missing value, ideally you should not give a tick mark here. Replace the missing value with average mean value. But if you are not able to do that, then give a tick mark here. Estimate means and intercepts. Now what output we require? So you just click on output. There is an estimation, there is a numerical, there is a bias, there is output. So just click on output here. Only one by default tick mark is present, minimization history. What we require standardized estimates. So give a tick mark to standardized estimates. Only a standardized estimates, right? And then close it. Everybody is with me? Analysis properties,
Yes, sir.
output, standardized estimates.
Yes, sir.
Then there is a box of calculate estimates. So you need to click on calculate estimates. So the model, the MOS will run the model. Once you will click on calculate estimates, the MOS will run the model. Once if it is perfectly run, then earlier it was not visible, this one. Only this one is visible, but it is now becoming the visible. View the output path diagram. So you click on here, output path diagram. So all estimates will come. Are you able to see these estimates? Got it? Everybody?
Yes, sir.
Very good. Excellent work. Then
Sir,
once
where
you
was that calculate button? Calculate.
this one on the right hand side, this one.
Okay. Okay.
Here. View the output path diagram. Now these are the unstandardized one. By default, you can observe these unstandardized estimates, but we are interested in standardized estimates. So just click on standardized estimates. Okay, standardized estimates. Now, what we require, all factor loadings should be ideally greater than 0.7 or greater than, at least should be greater than 0.5 and ideally should be greater than 0.7. So these are the factor loadings. This one, estimated one, the software has given us. These are the correlations. So correlation between organizational commitment and staying intention is 0.55. Correlation between organizational commitment and job satisfaction is 0.21. So in this way, these correlations can be interpreted. These are the correlations. and these are the factor loadings. Okay, got it, everybody?
Yes, sir.
Yes, sir. Yes, sir.
Now I want this path diagram in my Word file.
Yes, sir.
So what? Yes, please. Any question? Okay. I want this path diagram into Word file. So what should I do? I need to just click it here. Copy the path diagram to the clipboard. Just click it here, left click. Open a Word file. Open a Word file, blank Word file.
Kindly repeat, sir, please.
Yes, and then paste it. I am repeating it. Just click it here. Copy the path diagram to the clipboard. Left click here. Open the Word file and paste it. So in Word file, you will get your diagram. Everybody got this?
Yes, sir.
Like this, you will
Yes,
get
sir.
your
Yes, sir. Yes,
diagram
sir. Yes,
into
sir.
the
Yes,
Word
sir.
file.
Great. Perfect.
You cannot edit it, right? You cannot edit it.
It is sort of image.
This is, yes, it is image. This is restriction given by Amos.
Perfect, sir. Perfect.
Now, just a minute. Sir, PPT is not visible. Now it is visible. Okay, okay. You need to click it here, view text. View text. Once you will click it here, view text, then there is a file of Amos output will be present. Amos output, right? Everybody is with me? Got this one, Amos output?
Yes, sir.
Okay. You need to click it here, estimates, on this plus side, estimates. And then just observe the standardized regression weights, this one. Standardized regression weights. Because in output, these loadings are not clearly visible. Sometimes it will happen that if the diagram is too complex, then the loadings will not be clearly visible. So an alternative way is you can get it from here, standardized regression weights. So you can just observe this. You are not clearly audible, madam.
Sir, can you just repeat this Amos output, how to get this?
Okay. Is my Amos diagram visible?
Yes, sir.
Okay. Now you need to click it here, view text. View text. Okay. Once you will click it here, view text, then the output will be visible. Amos output will be visible. Got it?
Yes, sir.
Okay. Then you need to click on estimates. The first table is regression weights, second table is standardized regression weights. So that is what we are interested. These are the factor loadings. So for each of the variables, these factor loadings are visible. Then click on model fit. Model fit. Once you will click on model fit, then you will observe this model fit summary. Okay. Now the value that you need to report in the table model fit. So the first value for all the value that you need to report is for default model. All this default model is your model. So the value, the first one, the chi-square p value, it should be greater than 0.05. So it is here 0.002. It is not greater than 0.05, but it is less than 0.05. The problem may be because of larger sample size. Our sample size is 400. So report, then also you report this. Then the second thing that you need to report is C mean by degree of freedom. It should be less than 3. So in our model, it is 1.34. So it is perfectly acceptable. The third thing that you need to report is RMSEA. So RMSEA value, it is here. If you go there below RMSEA, and it should be less than, who will tell me? It should be less than error term. It should be less than, if goodness of fit is greater than 0.9, then error term should be less than
0.05.
0.10.
0.1. So it is less than 0.1, 0.029, report it. Then GFI value should be greater than 0.9, AGFI greater than 0.9, CFI should be greater than 0.9, NFI should be greater than 0.9, RFI should be greater than 0.9, PCFI should be greater than 0.5, PNFI should be greater than 0.5. So these are the values you can report it. All values are present into model fit.
Yes, sir.
Very good, very good. So this is how you can interpret the output and you can draw the model.
Thank you so much, sir. Thank you so much.
Your questions are welcome.
Sir. Hello.
Yes, please. Yes.
Sir, sometimes we are going with the help of process macro, and we are directly going through the output result with the help of certain procedure like mediation or moderation kind of thing. So
Yes.
is it advisable to go for this or not? Or
Yes, perfect. It is perfectly okay to go by process macro and directly you can get the result. There is a validity master file also available in which you can go for direct testing of validity, and all validity values will be calculated. Right. So it is perfectly okay. Perfectly okay. You can go.
Okay, sir. Okay.
Sir, for a paper to be written, first do we need to find out the factors and then we can go ahead with the CFA, isn't it, sir?
Theoretical background must be there, first of all. Right. So without theory, there cannot be a model. So if a strong relationship you wish to test based on theory, then you can first of all from a single construct you start, For a single construct, identify variables that will represent the single construct. Then
Yes.
second construct, third construct. Then go for content validity. Give this one to the some of the experts. Delete some of the items. Maybe they may advise to add some of the items. Then add it also. Then go for pilot testing. Maybe 80 to 100 respondent for a pilot testing is okay. Then you check the result, whether the factor loadings are coming greater than 0.7 or not, whether the all these fit measures are coming according to the recommended value or not. If you found certain problem, then maybe delete certain items, and then after refinement you start with the CFA. Again you go for a larger kind of a sample, and then you run the analysis. Then you will not have any problem. But you will miss any of the steps by refinement, then at the last stage you may have certain poor fit statistics.
So what should be the minimum sample size for this CFA to be run?
150 to 300 is recommended by this popular book. In between 150 to 300.
300. Okay, sir.
Excuse me,
Thank
sir.
you.
Yes.
So what if I don't get the fit indices to the required level? Then what should I need to do?
There is a procedure of modification indices. Because of time limitations, I am not able to do it. But I will tell Dhaval sir, he will definitely take you towards the modification indices.
Okay.
Right.
So that is visible in the analysis
Yes.
only. I saw it in the analysis.
Yeah.
Alright.
It is
Alright, sir.
it is here, modification indices.
Sir, now please, can you tell me, sir, how to, sir, just install it, sir, the problem I had?
Because we are on live session, so I cannot discuss it here. Once the session gets over, I will sure tell you.
Okay. Sir, can the study can be do for the dependent and independent relationship type also? Can some of the construct can be independent and one is dependent?
Please repeat your question.
Sir, just like in the regression problem, we are doing some variable are the independent, and we are doing the study for some dependent variable in finding out the impact of one's variable on. Hello.
Hello.
Ji, sir.
Your question is, can we do it for dependent independent relationships?
Yes, sir.
Yes. So you can do it independent and dependent relationship between the constructs. Here in SEM, what we are studying the relationship between
Hello.
6, the SEM part. What we have done. Hello, am I audible?
Yes, sir. Yes, sir.
What we have done at present CFA, stage number 1 to stage number 4. Right. So that what we have done, how well the measured variables are representing our construct. Now in next stage, maybe some dependent variables or independent variables are there. Then we can extend this model into dependent independent kind of relationships. And this is nothing but SEM. So tomorrow the entire session will be for SEM, how to test the relationship among the variable among the constructs.
Okay, sir. Okay, thank you, sir.
Sir.
Yes.
Sir, since we are developing this model based from a theory, as you have told, so is it will it be appropriate for us to do exploratory factor analysis first on the data and then later on to CFA?
If we do not have any idea regarding how many factors are present or which variables will load on which factor, if we do not have any idea, then ideally we should go for exploratory first of all, and then we can go for CFA one. But if we have a model available, some researchers say, for example, servo pool model, everybody has tested. right? The model is already available. So we can directly adopt that model, and then we can test this model, and then we can test that whether the data fits into the model or not.
Okay. So for example, if we are developing a scale for a construct, in such cases, we have to do EFA first.
EFA first, because if you are developing it, so first of all you need to do the EFA. So, and at the end of EFA, your construct will have a fair amount of variable representation, and then again in CFA, maybe in second stage by CFA, you can confirm this scale.
Okay.
So first EFA and then CFA.
Okay. So thank you so much, sir. And one more observation, one more question I have. How to establish the validity, convergent validation you have explained?
Because of time limitation also, I am not able to do it. But I have a file available, Excel file, in which you need to just copy and paste these two things, these two tables. That I will share, and then PPT also I will share that how to check it. Right, so it will be clear. Just 1 to 2 clicks, and then it will be perfectly okay.
So we will be able to do this average variance extracted, all these things will be able to.
Yes.
Okay.
You need to just this copy and paste these two tables, the table of correlation and table of standardized estimates.
Okay.
Yes, sir.
Right? I will share the slides with you.
Do it, sir. Directly, we don't have any option of doing it in AMOS.
No. Directly, it is not. We cannot do it.
Okay, sir. Thank you, sir. Thank you very much.
Thank you.
Someone, please start your video. Please ask to start your video.
Sir, can you
Ma'am, please open the video first, then ask.
Thank you so much, sir. The session was really very fruitful.
Thank you.
Yeah, if anybody wants to ask anything, they can ask. Okay, Hitesh sir. So
I cannot install the AMOS.
Is the session over, sir?
Yes, we can now.
Okay, sir. Okay. So thank you so much, participants. Thank you so much, sir. Wonderful session today.
Thank you, sir.
Practical knowledge also. And tomorrow is the 7th day, last day of our workshop. And I hope you all are learning so many things. And sir will share with me the file which the Hitesh sir was talking about, Excel file. I will share with you all. And tomorrow Dhaval sir will take the session. And Hitesh sir will also come tomorrow, as it is.
Yes, sure. I will come.
Validity day tomorrow. So thank you so much, sir. Once again, thank you, Hitesh sir. Thank you all the participants. Thank you, Mansi ma'am. Thank you, Sondi sir. Thank you, Shilpa ma'am.
Thank you, sir.
Thank you, everybody. Thank you, Ujjwal sir. Thank you so much. And I will try to share today's video. Actually, we are facing some error in recordings, but I will make it sure that I can share with you all today's video also. Thank you, Khan Saab. Thank you, sir. Thank you, Hitesh sir, once again. Good night.
Thank you.